Hello everyone, this is Bradley. Today this is a voiced recording to make a new particle dissolution effect in Blender. I've done a tutorial in the past, but the quality of it was kind of low in my opinion because I just changed my laptop and the microphone needed some adjustments. But the similar concept has been repeated over and over again in many following tutorials. Today, I do this voice recording. One is to refresh the old bad tutorial in my opinion. The other thing is that I want to try a different method. So let's start. So here we're in Blender. As always, I'm going to use the presets which you can download for free from the link in the description. Let's start with a plane. We can actually start with the sphere because we are going to emitting particles from this icosphere. And what we're going to do is just to distribute the points. We're going to distribute on volume. So we mesh to volume. And we take a volume distribute points in volume so that we distribute the particles. The density should be as much as possible. And we are decreasing this interior bandwidth. So now we have lots of particles and we basically just need to trigger them to fly. Next, let's add a simulation zone. It's always very nice to add simulations in this kind of effect because you can add a noise as a velocity. So all values you input into this offset within a simulation zone will be turned as a velocity. As you can see, this ball is moving to the right. And here what we are going to do is just to take a noise 3D. This is equivalent as noise texture. But the problem is whether you put this noise texture, okay, the frequency is too much. Let's decrease it. Then you can see they will converge to some points, which is not very nice. And the same problem is the same because they are basically the same. Okay, so to resolve this kind of problem, there is a noise turbulence. This is a very complex mess inside, which I don't even understand. I just took and use it. So it becomes like this. So points do not really overlap. They will continue to move, which is very nice. The only issue is that you need to tweak a little bit about the scale so that it looks kind of acceptable. Okay. But now all particles will start to emit at the most beginning. I want to have a kind of a triggering effect. I talked about this trigger system in this channel for many times. Basically, we evaluate our trigger and we output a trigger status. This simulation output will feed back all information to the input. So we get a trigger status from last frame. And if from last frame it's already being triggered, then we will use this old trigger status instead of the new evaluation. So this is the concept. So here we're going to use a proximity Fallloff to trigger it. And I'm going to use an empty to drive this trigger evaluation or the proximity Fallloff for trigger evaluation. And then we need this trigger status to define whether we move this point or not. So now if I move away my controller or empty, you will realize they will not have a noisy effect on these points unless I touch them. So this is the concept. Here I want to warn you, because this is a common mistake even for me, that these two linkage actually contains completely different set of data, because the position used inside is being moved with this set position. This is a common feature within field of our geometry nodes. So to solve that, we need to capture the attribute so that we make sure we're evaluating all information before we set a position. Okay, so this is kind of very important. So now we have this effect. Up to now, there's nothing really new. Everything has been discussed in the past. Next, let's dissolve our object. In the past, I dissolved it by deleting geometry. Where's our geometry? Yes, we have an icosphere at the most beginning. We can join it at the end. And in the past, we delete this geometry. So I guess we delete it by face, and we use the same fourth. So you can see the top will disappear. And this is very ugly, because you can see through inside. It just doesn't look great. So I'm going to use a different method. We're going to create a volume of it. So let's create a volume cube. It's essentially generates a volume cube by default. But in actual principle, what it does is that within this bounding box of minimum and maximum, you're giving the density 1 to this volume, which also means that you can control this density. So here, I think what I'm going to do is that we know that this icosphere is having radius of 1. We can take a position. So we're reading the position within this volume. We take a length. And if we plug that in, you can, I hope you realize there's something happened in the center, but it's not very obvious. So we take a comparison. We take a less than 1, because the radius of icosphere is 1. Then ta-da, we have a volume sphere, and we can mesh to we can volume to mesh. It looks kind of very ugly. Adaptivity doesn't really help anything. We can smooth position, which is basically a smooth modifier, maybe 15. So we have a very nice looking sphere. So this looks kind of okay now, but to know this is actually a volume, which means that if we're deleting it, so we remap 0 to 1, and we multiply these two effects. So I'm reversing 0 to 1, and I multiply with the previous result. It doesn't happen anything for now. It's not changing anything, and it's very difficult to visualize the changes. Oh, but we can visualize the changes as we are scaling up, you can see there is actually a volume involved in this effect. So I think the reason this reverse is not working is because how this density is being counted. So we take a color wrap, or we can take a compare. Okay, so this is fine. So we only include this, we only generate this volume if the threshold is over 0.6, something like that. Okay. So now we do not only generate particles, we also generate this volume. So now we can actually see how this animation actually looks. If I play this animation, I scale up my empty, it's emitting particles, but at the same time it's actually deleting this icosphere volume. So now we finished the basics of our animation. The rest is just to polishing this entire setup and keyframing it. One thing is that we can remove this remap 0 to 1 and we make that less than to reverse the evaluation. Okay, and let's keyframe our empty. I don't usually like keyframing empties. I talked about the reason. I usually suggested that you set up the fourth, the gradient, and then you use this fourth animation to animate it. And you can use this fourth animation to fully increase the value. But for simplicity of this tutorial, I'm going to just keyframe it. So let's start with a small scale. Add a keyframe, goes to 225. Add another keyframe after scaling up. So now if we play this animation, this is what we're having, and we can tweak a little bit the settings so that this volume is being decreased earlier. Okay, and note that we're really having this kind of volume decreasing, which is very nice. And here I'm going to add some noise. So we take a vector noise and let's delete these particles for now, so that we only see this icosphere. You can increase the frequency of this noise so that it looks kind of more interesting. So eventually we have this kind of effect. And let's add a set shade smooth. And we may increase iterations or decrease iteration. It's completely fine. You can tweak settings by yourself. And I think it's kind of very interesting when you combine the effect with the particles. We have too many particles, but I think it's fine. Here, let's add some materials to this setup. I'm going to add a set material. And for our icosphere, let's add a default material. I'm also going to store a named attribute, which is going to be our fourth, so that I can set a kind of color transition with it. So now if I take a look with our mesh, and here's our fourth. So initially looks kind of black, then we have a gradient of white generated due to our fourth. So we take shader editor, and let's go to attribute. We have this Fallloff stored, and we put that into the emission. So let's color ramp it. So now if I delete this viewer, goes to material preview mode, you can see this effect. And let's add a red color, increase the strength of it, and we add a bloom. So now we have this kind of effect. And then we add the particles, which is also going to be an emission shader. So take an emission shader, goes to red and 35, and we find it's not being rendered because eevee cannot render these points, but the cycle can. Cycle can render these particles, but the eevee cannot. So you have to point instance. Let's increase some low-level geometry. You may use some UV sphere. Maybe just make that into 4, 4. And we decreased scale of it. Okay. So now we have this kind of effect. It looks kind of cool. Here I can also decrease the scale of these particles if they are too old. So we need to record a trigger time. I talked about this in the past as well. We basically do the same as we are doing with this trigger status. So we know the birth date of this particle emission. So we need to know the age. And age is essentially just current time to subtract your birth date, so that you know that you're 18 years old, 25 years old, billion years old, and we can construct a Fallloff with it using a map range. Map range is a little bit too large for this kind of purpose. So I made a tiny one. I call it time Fallloff. The duration is 25, so it's like 25. So once we have this Fallloff, it goes from 0 to 1. We just plug that in. What it means is that we start from a very low scale point that you do not see, but then it becomes larger. You can remap it to larger scale. The good part of having this kind of a Fallloff in 0 to 1 is because that you can also float curve it. So we start from 0, and then we get a maximum number, and then after a certain age we decrease it as well, and we can manipulate the curve off. So now we have particles generated, and they're being killed very fast. So this is kind of idea. You can also see that it solves a kind of problem that previously that we are having some particles being visible at the most beginning, but because we eliminate the scale when they're too young, so we don't see them. So this is just one way to solve it. There are also other things that we can do. For example, we can control the emission velocity. Right now, this is more kind of a coincidence that this noise is going that direction. But it's very possible this particle is going that direction or that direction, which is colliding with our own object. But that's too complicated in my opinion. I don't want to dig into that for now. Okay. At last, I want to remind you that it may feel like this setup is only working for an icosphere because of the operation we working here is to generate an icosphere. But actually this setup can be worked for any geometry. So we can work with a Suzanne monkey. Or let's take a cylinder. Suzanne monkey is a little bit difficult to talk about because I don't want to spend too much time. Let's just create a cylinder. And obviously it's not easy to use this function, but we can use a new function instead. We can use the inside the volume function. Basically we're determining if this grid is inside the volume or not. So if we take a geometry, if it's yes, then we're generating a cylindrical volume. I think I will talk more about this volume cube in the future, but for now this is like the case. So we basically do the same with the setup. So now we have a volume cube disintegration effect, something like that. And at the end is just to tweak values about this kind of volume setting, threshold, and so on. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.